Hello, everyone. My name is David Guajardo. We're going to conduct a podcast, and today's guest is Ken Hernandez, an aerospace engineer specializing in space flight dynamics. Ken works at L3 Harris Technologies and used to serve as a former adjunct professor at Florida Tech. He is a former U.S. Air Force officer who served as chief orbital analyst instructor for NORAD and even trained as in air combat maneuvering flying the F-15 Eagle. He holds degrees from the University of Colorado at Boulder and has 2 patents in Kalman filtering applications. Ken has worked on Napster GPS, the GOES-R meteorological satellites, and is part of the team developing amateur radio equipment for both the International Space Station and the future lunar base in the South Pole. He also teaches with us here as a director, supporting our OPS 502 and AST 501 courses. Ken, welcome to the IIAS podcast.
Well, thank you very much.
Let's start with the first question. For listeners who may not know who the IIAS is, can you tell us how you first got connected with the IIAS and what drew you to join our academic community here in Melbourne, Florida?
Okay, so I started with the IIAS because I was interested in the Introduction to Astronautics course. And as soon as I became acquainted with the community, I saw what a vibrant community we had here and saw many different opportunities to help not only myself grow, but help the community grow.
Fantastic. You help us teach OPS 502 orbital mechanics and contribute to AST 501, Introduction to Astronautics. What excites you most about the students coming through the IIAS programs, and what do you think sets the institution apart from traditional aerospace education?
Well, a lot of what I see as part of the students is the quality of applicants that we get, and the quality of the students coming through seems to be progressively improving, which means either people are getting smarter or we're reaching out better and attracting a higher quality of people.
Absolutely. What do you think sets the most common misconceptions students have when they first encounter orbital mechanics?
Well, a lot of people don't understand that gravity is essential for something to orbit. They think gravity is the enemy of a spacecraft and is going to pull it down, and it does pull it down. But to orbit an object, gravity is quite essential and is needed to make it all happen.
Yeah, normally you put our students with a headache when you first introduce your class with them, and they seem to have trouble. And then after a couple of hours with you, they come out super excited, very happy to learn. What do you teach them in that time frame?
Are you referring to the aerial mapping?
Yes.
Okay, so that's part of the introduction to astronautics. And they have to actually plan a flight and conduct it in an aircraft where they have to image a target, and they come in completely cold on that. And I teach them some essential manual navigation techniques, and it develops quite a few skills on that.
Did you create that portion for the class?
Yes. Actually, my class, which was the class of 2001 with IIAS, we were the first to be introduced to this exercise. And we had to figure it out. And because of my background in nautical navigation, I was able to kind of spearhead that. And we went through a few iterations before we perfected it.
How important is flight dynamics knowledge for future astronauts or space professionals now that you're working on the future lunar base? What can you tell us about that?
Well, flight dynamics is fundamental for any type of lunar orbital travel or anything, because there's a lot of it that seems to be counterintuitive until you can relate it to things that you experience on the surface of the Earth. And once I can make the proper analogy or metaphor, it becomes actually quite intuitive, and it's necessary to be able to fly the spacecraft.
So, Ken, not many aerospace engineers can say they trained in air combat maneuvering flying the F-15 Eagle, which is an impressive aircraft. How did that experience change your understanding of flight dynamics? And does it ever come up in the classroom?
It usually does not come up in the classroom other than a gee whiz sometimes, because I actually, very first time my squadron commander was a very famous pilot from the Vietnam War. He participated in Operation Bolo and did some of the planning and was the first one to shoot down a MiG 21 in that battle.
I believe your experience is extremely unique, going from military service to industry at L3 Harris to academia. How do each of those words inform one another in your work?
Well, they all mix together very nicely. And what I like about the classroom is that I have students come in and they get very frightened about the space flight dynamics because it is one of the more difficult courses. But in the end, I get some very good reviews because they realize that it can be explained in something that people can understand.
Absolutely. You translate it in a unique form. And most of our students that come here from different countries, they also serve a military and they also are trying to get the same experience as you did. So, do you find applications directly oriented to their own careers?
Yes, I do. And I will say also that in the intro to astronautics, the flight in the extra aircraft, which is a high G aerobatic flight, is very, very close in performance to the experience in flying a high performance fighter jet.
Yeah, changing a little bit to satellites because you also have experience on that. Most of our students are very interested on that. You work on Navstar GPS, and the goals are weather satellite series. Most people interact with GPS every day without thinking about the orbital mechanics behind it, which you are an expert at. Can you pull back the curtain on what makes those systems so complex to maintain and operate?
Well, one of the most important things is that most people don't understand GPS. Yes, that stands for global positioning. It has a prefix name called Navstar, which is navigation, satellite timing, and ranging. Timing is extremely critical, and to be able to get the kind of accuracy you need to navigate with GPS, we're talking about picoseconds of accuracy on the clocks, and your receiver has to synchronize to that level.
And behind that, you create the algorithms for that to happen. Is that automatic, manual, or how's that interaction?
One of the things that we did was we created what's called the monitor station, which has high accuracy atomic clocks. But we also came up with a unique way to synchronize the clocks and to be able to get ranging down to the centimeter and maybe even the sub centimeter level of satellites that are 20,000 kilometers above the Earth's surface.
That's impressive. Now, the global positioning system, I we've read it in aviation. The teaching it's that at least there's needed three satellites for that to be implemented, and a fourth, which is redundancy. Is that still the case with GPS systems?
It's an inherent it's an inherent need actually, because the four satellites is actually a necessity, not a redundancy. So the fourth satellite is what solves the time. So you have three spatial dimensions and one time dimension, and that's what's needed to synchronize the clocks to that level. What happens is the more satellites you have in your view, and you mentioned about Kalman filtering, what that is a way of averaging and removing much more error by having more data sources than you need.
This is very important knowledge. Honestly, Ken, I thought it was only for redundancy. I didn't know it was actually active and serving a purpose. Now, how many countries have their own GPS systems?
What I'm aware of is that, well, the US started with the GPS system. The Russians came up with the GLONASS, Global Navigation Satellite System. Europe came up with a system, as did the Chinese, and I think maybe even the Japanese have their own system as well.
Now, going to your radio experience, you're part of ARIS team, putting the new radio system on the ISS, and now the AREX team developing radio equipment for the lunar gateway or the lunar base in the South Pole, what are the biggest engineering challenges of designing hardware that must meet NASA's crew safety requirements?
That's a really important thing because anytime you put equipment on board a spacecraft with a human crew, there are very stringent requirements for safety. And I can tell you that it would probably be about 10 to 20 centimeters thick if you printed out the documentation for that. So to go through that, meet with the safety crews in Johnson Space Center, identify the potential hazards in the equipment, and figure out how do we mitigate or eliminate any hazards to make it adequately safe and also not impact crew comfort.
Isn't that too extreme, or is that really the thickness needed to? I guess that's for radiation purposes.
There's also acoustic problems. There are problems that you could have something that could shatter. Think about something shattering in microgravity. If you had glass shattering floating around inside the cabin, that somebody could potentially ingest or inhale that.
True. Yeah, it's been said that the new administrator, Mr. Jared Isaacman, he changed the rules or make them more efficient in order to bring, for example, iPhones, which is what personal devices from those astronauts can record, can take pictures, can share it with the world. And he accelerated that. And they were talking about that, about the lithium batteries inside. What can happen if that device explodes? What happens if it shatters? So I guess it's super important to check the minimum details for the filters.
That's extremely important. And the crews had been allowed to take iPhones. And a matter of fact, our radio station, a big part of it's a power supply that had um, universal serial buses on it that they plugged their phones into. But yes, it was very limited in what they were able to do. And Mr. Isaacman, being the person he is and the entrepreneur he is, realizes what's important and what isn't.
Now, I believe, Ken, you went through the transition of the Lunar Gateway all the way to changing the ambitions of the US, removing that and going all the way for a lunar base. Do you think that's a right strategy?
I think it's a very good strategy because being able to do and the orbital dynamics to intercept and dock with the lunar gateway adds a level of complexity that we're not quite ready for. So that may be something that we do in the future, but going directly to the lunar base and having a permanent presence there is very, very important.
And on the lunar base, do you think what do you envision on that? Is that going to be underground?
I'm not sure how they're going to do it, but there is a good case for having an underground portion of the lunar base because the regolith would be a big help against radiation protection, which is a big hazard for any human in space.
Yeah, just as a first space station that the U.S. developed, I believe that was the second stage of the Saturn V. Is that correct?
It was the third stage.
Sure.
It was called the S4B. And instead of having an S4B, they converted it to a space station,
which was named
Skylab.
Skylab. Good. I've heard or read that one of the ambitions or the plans, they could do the same with Starship, the second stage.
I have no doubt that they can do that. And I have an awful lot of confidence in what Elon Musk can accomplish. I watched SpaceX from its early days when they struggled, and it was a lot like the early US program. Yeah. But I think he has the right formula: fly often and fail often to learn where all your flaws are.
Yeah, and it's the holy grail of the rocket industry, having a reusable rocket, rapidly reusable rocket. So hopefully they can succeed in that in all the bases and the new factories that they're developing here in Cape Canaveral and also in Starbase in South Texas.
Yeah, and that was something I had some doubts on, and I'm very pleasantly surprised that I was proven wrong on my prejudice of that. No, you can't reuse rockets. You're adding too much weight and complexity to do that, and they prove me 100% wrong, and I'm delighted that they did so.
Yeah, mostly the capabilities that that rocket is going to have. I believe that's gonna definitely create a difference in the aerospace industry, the space industry, or the future, what they call the neo space, based on the heavy launch systems that they're wanting to accomplish, which is in between 100 tons up to 200 tons, which with two launches you can create a second international space station.
Which is amazing, and it's the sort of thing that we really need to have happen. If you look at aviation early on, there wasn't a lot you could do with it. Now look at how normal it's become for people to just buy a ticket and get on a plane and fly wherever they want. And that's the natural evolution that we want to have happen.
How far do you think we are from antipodal transport, let's say going point A to point B anywhere on Earth in less than 40 minutes?
If you wanted to do it badly enough, we could do it within the next 10 years.
Wow, that's amazing. Did you transition from having a difficulty boarding an airplane to all of a sudden millions of airplane rides around the world on a monthly basis?
It's entirely possible. It's just how is there oftentimes the market drives what happens, and when there's an actual economic need or some other need for it, it then suddenly happens.
Yeah, that's one of the expertise that I admire about SpaceX is not trying to rely less on the government, less on space funding, and more in the economic side with actual normal customers and enterprises, which in this case, they along the way of the creation of this company, they found Starlink, which is a business case to succeed and to actually invest those profits into the Starship program. So definitely, that's something that also Mr. Jared Isaacman is wanting to push NASA to find those economic purposes so the programs can pay for themselves. I believe that's very important rather than relying in the investment from the government. What do you think about that?
Well, I think we've reached the point early in the space program, there was no possible way to do it without government. We have matured enough that, and what SpaceX is proving is, yes, this can be a very profitable industry, and it's now the next step in our evolution, really.
Yeah, everything's changing right now. You probably read about the changing in priorities for the company. Instead of going to Mars, now going to the moon, which aligns perfectly with the new NASA goals as well. Now that we are in competition with a different country. So we need to find ways to go there and stay there and create more lunar bases, maybe an actual factory of AI satellites, which they announced it. So I believe the future is bright, and we can see that, as you mentioned, in the next decade.
There's an awful lot, and what's going to come out of it is things that we can't even imagine right now. So you might have certain things you do imagine, and some of them will come true, but there's also going to be things we're not even thinking about right now that's going to come out of it. If you think about it, the Apollo program advanced technology to where we have the computers and cell phones and a lot of other things we take for granted today that did not exist before that.
That's just fascinating. I love what you're saying, Ken. And you touch an important topic, which is calculators, computers. It's well said that with less of the power or the intelligence that we now have in our pockets, in our cell phones, we went to the moon. Is that actually true? Why do people don't believe in that?
I'm not sure why they don't believe in that, but I had spoken with Charlie Duke. He was landed on the moon in the Apollo 16. He was the Capcom when Apollo 11 landed on the moon. And one of the points he made is, if we were going to fake the moon landing, why did we go back 7 more times and even have a failure in there? Was that to make it look good? And if you look today, there's other countries that are imaging our lunar landing sites. And surely if we had faked it, the Russians would have known that and would have told everybody.
100%. Yeah, it's because I believe the majority of the population, they think that we've only went once. And as you mentioned, there were 7 missions and all of them successful if you take into consideration bringing back the humans with life. But yeah, as you mentioned, the other countries have actually captured that. And there's even the laser, one of the experiments is still there and you can still prove it.
Yes.
Now, going to a different question, this is one of your, I guess, favorite topics, orbital mechanics.
Mhm.
It has a deep classical roots, Kepler, Newton, Gauss, but the operational environment is changing fast with mega constellations and commercial launch cadences. How are you evolving the curriculum at IIAS to reflect that reality?
Well, I've always tried to stay ahead of it, but I also use the historic precedent. For example, a lot of people with the recent Artemis 2 mission had never heard of a free return trajectory. And in the textbook that we have for the orbital dynamics at IIAS, it's shown there. And it's almost exactly the mission that Artemis 2 flew. And I demonstrate for the students how that happens and how you can do that, and also show them how you could alter that trajectory and put it, instead of flying around the moon, get it to orbit the moon.
Wow. What do you mean by free trajectory? Is that, do you mean if something goes bad at the middle of the mission, that spacecraft is going to be getting back to Earth?
Exactly so. And if you remember, what was interesting about Apollo 13 is the accident happened right after they departed from a free return trajectory,
Wow.
because they needed to go off of the free return trajectory to land. Now, with Artemis 2, they did several things that were extremely safety conscious. The first thing they did is go into a highly elliptic Earth orbit to check the spacecraft out. If there was any issue within a day, they could have returned to Earth. Once they were confident in the spacecraft, when they flew around to what's called the perigee, which is the closest approach to the Earth's surface, that's when they did the translunar injection burn, which departed and flew out to where the moon would actually run into their path, and they would swing around. And what is a free return trajectory literally meant that, in theory, you fired that burn and you would fly around the moon, and if you did nothing, you would return to Earth after you swung by the moon. Normally, you have to do a lot of trim burns. Artemis had to do very few trim burns to actually complete that return to Earth.
And that is getting more efficiently done and more accurate, I guess, than, for example, Apollo. Are those lessons learned, or it's just improvement in the dynamics and computers?
It is both. So there was a lot of lessons learned, but the power of the computers also helps us to better be able to fire thrusters more accurately, to be able to compute things on the fly in real time. And we're working towards being able to teach those techniques in an immersive environment with the IIAS space simulators.
Now, you mentioned firing the thrusters, and I remembered yesterday, just yesterday, when we got the visit from Steve Agate, and he also talked about some errors that happened in the other US capsule. What do you know about that?
Okay, what he was talking about was the Boeing capsule, which is called Starliner. And again, what the conclusion from what I got from his talk was that Boeing went with the old traditional government model. SpaceX, with half the budget, went with the newer model and was far more successful because they were more conscious of a lot of things, and there were a lot of management issues with Starliner, and they could have lost that crew.
Yeah, one of the differences, which I don't know if it's good or bad, but you mentioned about the thickness, right? About the components in the lunar base, for example, or going to higher orbits, which you require more protection from the radiation. Now, I've also read that SpaceX has played with some components that actually exist in any market, Home Depot, for example. What do you think about that? Reducing costs using normal components.
Well, there's a long history of flight qualifying hardware, but I've also been involved in an amateur radio organization called AMSAT, and they pioneered satellite development using ordinary components that sometimes you could buy at Home Depot. So none of that surprises me that SpaceX can recognize when a component is actually good enough to qualify for space use.
That's a perfect word. Good enough. And that can bring down the costs in the millions. So it's very nice to see newer companies trying to play with that to get it towards where it can be safely used and also save the millions, which is very important and very needed. Now, Ken, what's one concept in orbital mechanics that consistently surprises or challenges students the most, and how do you tackle it?
Well, the very first concept that's challenging to people is why does a satellite orbit? Because I show people that even at the altitude the International Space Station orbits, it has more than 88% of the gravity at the Earth's surface. And why doesn't it fall out of the sky?
Yeah.
And to be able to explain that the International Space Station is moving so fast that it's literally outrunning gravity and it is falling all the time, but that's what causes the orbit.
Yeah, including all the, what do we have now? Maybe 10,000 satellites in LEO?
I'm not sure what the number is. There's also an awful lot of debris up there, which we're trying to work. And that's going to be another business is debris mitigation and how do we clean up space?
Yeah, hopefully there's going to be new relations internationally. I've heard some other countries lack the willingness to be more conscious. So hopefully that can be fixed.
Yeah, well, it's the same as when we started. We had no cognizance, or we didn't really think about the trash that we were leaving up there, and now it's starting to become a problem, and
Yeah.
things have to be done to make that not a problem.
Ken, for someone listening right now who is considering applying to an IIAS program, what will you tell them about what to expect and what it could mean for their career?
Well, I think that you'll find it to be a life changing experience, that you're going to learn an awful lot in a short period of time, and you're going to meet some of the most fantastic people you'd ever want to meet.
100%. I agree. And that's very nice. Ken, beyond the classrooms and the lab, you're a private pilot and a master scuba diver who does underwater videography. Is there a true line between exploring the sky, space, and the ocean that connects all of those passions for you?
There's a lot that's similar between them. What you learn as a scuba diver is extremely important in a lot of ways for life support surviving in space. Flying an airplane, you learn a lot about crew resource management. Now, the way you fly an airplane has some fundamental differences from how you fly a spacecraft, and that's what I will be teaching in an upcoming course on how you actually fly a spacecraft. And the pilots will find it acceptable and they'll learn that it is different, but that they can do it.
And all those disciplines that you mentioned, we actually practice all of them just in the first class, AST 501. We put the students in an extra 300 aerobatic airplane up to 6Gs, maybe more, which is impressive. And we also have the EVA underwater courses within our own underwater laboratory, which is fantastic. But you mentioned a new course that you are developing. To end this podcast, can you tell us more about that? What are you doing?
Okay, so the AST 502 course teaches the theory behind orbital dynamics with a lot of practical reinforcement using a NASA software program that anybody can download because it's open source. This will now become an immersive experience in a simulator that has been told by people who know and are experts as remarkably similar to the Orion space capsule and functions very much like it. And in the immersive part of it is that they're going to now apply what they learned theoretically in orbital dynamics and actually fly the spacecraft to rendezvous and dock with the International Space Station, and also go through the reentry, atmospheric reentry and recovery portion, which segues into another course that we teach.
You also mentioned some textbooks. Have you developed or helped co-author some of the IIAS textbooks?
Yes, I authored the spaceflight dynamics from the ground up, which is the textbook for the Ops 502 and Ops 602, the upcoming course. And that teaches orbital dynamics on three different levels, where the first level is just a familiarity that anybody at the level that somebody would read in a popular magazine. And then it transitions to what are the equations if you want to program it into a computer. And then for those who really, really want to understand it, it goes to the level where we actually derive the equations.
Ken, it's been fascinating to hear about your expertise, your passion that you bring to the Institute, to your own career, bringing down to normal people like the students at IIS and myself. So thank you so much for keeping us learning more about the future of the space race and also the next experiences. So thank you for coming today.
Well, thank you for the opportunity. And I also look forward to anybody new who's interested in the Institute and getting to meet them and working with them.
Thank you so much, Ken.